For this, should I leave something? Something like, come up. Very good morning, students. So we welcome you all for the second day value added program. So today with us we have Dr. Ratna Kirti Roy, HOD Department of MCA. So I want all of you to, we want from the department, we want all of you to utilize the session by sir. So I request Professor Geeta Lakshmi to welcome the Ratna Kirti sir for the session. It's not true. Oh, yes, yes, we are ready. One to all the game. Yes. So, it's a so I don't think it's a people. When it's all so, what you young for your mom. So, what do you think calling? So, we have don't tell it is fine, don't tell it is also fine. So, now we have some more. If you do anybody here is additional the marketing coding, anybody have the reading coding in the code shell or in code, anybody? No, okay. It's not a problem. You will be doing in some in 1 year possibly. So when the industry wants to hire, okay, when the industry wants to hire students, specifically from the technical branches, from computer science, engineering, very specific. They, irrespective of whatever degree you are studying, maybe the CSE or an ISC or an MCA or whatever, they came whether you can solve a problem. So problem solvers are more important than keys. Please understand that. So we will address that part of how exactly what are the features know or you don't know and how we can solve problems using an ad. There is a problem already approached. So just to go, just a brief outline of what I will be covering today. So we'll start with defining an array, which I believe all of you must be knowing by this time. We'll understand what the types of array we have. Then we have a and finally we can see blocks to go. Use that. So with like the flowers to that spread to the right and all on one so an array in very simple is a method of storing data in continuous locations of about real thing. Okay. Okay. If you say store data over in the then it is stored and saved in locations which are side by side, homogeneous and continuous. So that means if you have an integer array, I will not that will store the can over. So if I have a character array, so I will specify in that one, if I go to four one for every index. So arrays will always be homogeneous in nature. There are few key characteristics of an array. The first one being the homogeneous. Second one is string type. Second, before you use it in C, at least in C, since they are focusing more on arrays has to be fixed size. That means you have to specify how many elements be there in the array before you start using it. So we will see in the later stages that now the same we can do it in a static way and the using pointer, the dynamic memory allocation. And obviously it is continuous memory allocation. And the fourth point you see on the slide, there are no automatic rules checking in case of an array in C. So what exactly is the rules checking? So while you are programming with arrays, has anybody come across errors when you are say writing code or you have been given some assignment, you are writing them on the say machine. Have you come across errors like array index out of bound? Anything simple example like matrix multiplication or maybe addition or whatever. Have you come across this array index out of bound? No. Okay. So that means you had say got the codes right, it did not overrun. Now what is that? So in case of an array, I say it's a fixed size. So for example, if I have a size of 40, an array has a size of 40, then C as a language will not check whether you have used more than 40 spaces. So by checking, I tell that there are two phases of checking the say language level. Either at the compile time or at the time. So at the compile time, the C language does not have any explicit check on the so we are in comparison one so if you are working, no one will be using it, and you are doing 40 or 45. So types of arrays in C, I believe the most common ones you have already known. The single dimensional and the unidimensional array. And the both jagged arrays, anybody? So jagged array is a kind of array. It's a two-dimensional array, but every row has a different size. Okay. So in a two-dimensional array, what we have? So we have few rows, right? 12. And all the rows have the same number of terms. Now, if I change this and make it the few rows or maybe all rows have a different that generates something called a shared array. In case of C, we do not have a unique mechanism very much. We use pointer to do anything. Only like Java and reduce what the shared arrays. And we also have something called pointer arrays. So everybody knows what's a pointer. Pointer is going to be very important now when we gradually go. So anyone, what is a pointer? One of you bring one way. Volunteer, anybody? Just to tell. What is a pointer? Anything that you know. Whatever you know is fine. Decide. Can I say, can I get to know what is a pointer? So no one has worked with a pointer. Yeah. What is it? So pointer is it a variable? Is a pointer a variable? It is not a variable. So what is it? Derived? That's right. So what it does, it points to the energy from the and that's what we are again. So when you can in can we instantiate and initialize an array? There are certain steps. These are the critical things that we need to know. So the first thing is also required when we solve a problem usually. So how do we solve the problem? So actually, we all here are possibly we have been getting problems from studying. You get direct problem. So possibly you will be design two matrices. You must be required to multiply them or add them. Or for example, you'll be given one array and you'll be told that okay, you have to sort it or reverse it or whatever that means. Whether we go for problem solving in the industry domain, you will not be given 8%. So what we will have is we have problem theory. So if you could require an array to solve. By seeing the problem actually you have to understand the idea and array to solve. So what's that? I believe it is audible. Yeah. So one we can see so you speak to me take action. You can cover. They can hear my voice. You can get it. To understand size. Why the size is important and the type of the array? Because say you you are requiring an array of size 50. Now I'll just take your experience. When you were declaring an array, what was the size generally you were giving?
100, 200, whatever you found in mind, you have to type it. But did you use actually this all those 100 points or 200 points? You did not use. So for the learning purpose, it's fine that you don't use your machines are available, you do work. But when you are actually working for a practical problem, then your space requirement is as important as the problem itself. So ideally, if I am required to use say 50 spaces, I would have to understand I require 50 spaces. So I will not be allocating 100 or 200 because I will be wasting that space. So it will not do any error, it will not show anything, but it will waste on the space. So first thing when you are using an array, you have to optimize on what is my space requirement, how much space do I really need. And if there is a provision that is not there in C, that you cannot extend or expand or shrink an array at runtime. Languages like Java and .NET frameworks do have that you can expand and shrink at runtime. Then we allocate the memory space. To allocate the memory space, we have two mechanisms. The first one is to allocate static way. That means before I use the array, I tell how much space it is consuming. I use the say whatever the usual syntax and I declare the array. In the second thing we have it dynamic. What is the advantage of dynamic memory allocation? Anybody can tell? Anybody has gone through dynamic memory allocation? Data structures you have gone through? Not yet. Okay. So there are two ways by which we can allocate a memory. Say for example in C, when you are declaring a variable, how are you declaring? You are writing int space variable name. What happens when you declare? What happens internally? Anybody any idea what happens internally? So you write int C. So what does your compiler do? Your compiler tries to allocate memory in the where does it allocate? Where does it allocate the memory? So if I write int C, where is this C existing? Anybody? Where does this C exist? So it creates a memory. So integer takes how many bytes? Say 2 bytes, 4 bytes, whatever. Where does it allocate? Where is it? Anyone? Wrong answers are appreciated. Anybody? So all allocation is in the RAM. So it allocates in the RAM. So similarly, when we declare an array or we allocate the space, we can either say this much of space I need, okay, and it will find a contiguous location. You will not be having the headache. It will do the compiler will take it up. It will allocate and forget. The second way is we can ask from the user really how much of space they need. So you know the printf and the scanf statements. You know the use of those, right? So for those, say I take the user input. The user tells me I require 30 spaces. Can I declare an array after that? That user tells 30 spaces. I also declare an array with 30 spaces. Now, if I want this flexibility to come in, that is, I will declare or allocate memory on the basis of what the user tells me, or for example, what the user tells the program, to be very specific. Then we would use the dynamic memory allocation for the same. Now, which version of C have you used? The blue screen one, or you have used the GCC, or you have used, say, Dev C, whatever, what have you used? GCC over Linux. So C has certain standards. Okay. The modern compilers that we now have, so if you go with GCC or if you go with Dev C or whatever, it follows the C99 standard. So previous to that, we had something called the C89 standard, which is still mostly followed in all the books that you have. In those books, variable declaration was extremely stringent and you had to do all variable declaration before you used a single variable. So initially, so I believe when you were taught writing a program, you have been taught that okay, you will have to declare all the variables first, then you will have to basically work with the variables. From C99 onwards, the logic has changed. So they have brought flexibility into the C programming language. So in after C99 standard for all the modern ones, which are doing with GCC and everything, you can declare a variable anywhere. So that helps us with the dynamic programming say approach or the dynamic memory allocation approach also that we will see. Then obviously assign variable name. How are you assigning variable names? We commonly assign at ARR, A, X, Y, Z, whatever. But anyhow, as an industry best practice, please remember that for any programming language that you learn, always name a variable with respect to the purpose it serves. Say for example, if you are say using two variables to be added, we write A, B, C, we write say C equal to A plus B and printf C, that is what is our logic. The program will be correct. But if you think from a larger point of view, for example, if you are writing a 5,000 line code or a 50,000 line code, which are actually normal lines of code when you are going for practical problem solving, then if you don't name your variable according to the purpose that they serve, so what happens is at the end of the time, if there is a debugging required, you will have to figure out what exactly is this variable, where, why have I declared. This is the first thing. Second is, so when you are going with, say you are working for a company, you have written some brilliant lines of code, brilliant coding you have done, say around say 2 lakh lines of code you have built one software. Then you leave the company. Somebody else comes to your place on the same project. When they are given the same program block or the 1 lakh lines of code that you have written, what happens? They don't find anything. They can't debug, they can't understand. So that is another reason why, as a best practice for programming, we always suggest that you name variables according to the purpose that they serve. For learning purpose, you do everything, but if you make it a say habit, that okay, I'll always make a variable, I'll name the variable according to the purpose that it serves. It always helps. So the variable name we assign and then we initialize. That means we set initial values. In case of C, if you are declaring an array, the spaces which has been allocated might have garbage values. You know what is the garbage? Anybody knows what is the garbage value? One of you just tell, you have been through it, right? Garbage value. Those are unnecessary or irrelevant values which are already present in the, say, my memory. So to initialize, what we do, why do we initialize? We initialize so that we can have a consistent set of values to begin with. We can initialize everything to 0 or 1 or whatever as per our requirement. The initialization is a important thing which we have in case of programming. So whenever using an array, we would also have to initialize it. Now, next we go with the static array declaration. Okay. So I believe this code that is over there is a very similar code. You have seen codes like this being written. So how do we declare statically? That is, static means we declare at compile time and we are not declaring it at runtime. So how do we do? Say I have taken an integer array with the name numbers, and in the square brackets I get the size. So it means that I am reserving 5 integer spaces of what type? Contiguous type. This is very important. In case of arrays, the memories are contiguous, one after the another, and we initialize them through index. Since this indexing is possible because it is contiguous. So we can have, so we start from 0. In case of C, it's a 0 indexed array system. So it starts from 0. So 0, 1, 2, 3 and up to 4, we can have the value. So we have initialized the value and we have the display. We can run a loop. So we know there are 5 elements. So we can run a loop and we can just print the elements. Okay. So this is my static declaration. So at any point of time, if you have any doubt, please interrupt and ask. Not a problem. Okay. Now, next we go for the dynamic array declaration. Have you done dynamic declaration of arrays? No, right? So you please take out your laptop, do it. You must understand how the basically this thing works. Please take out your laptop. You can take up any online compiler that will be faster. If you don't have anything installed, you can say use online compilers as well. So what they have here, you all don't have machines. I'm not brought. So one is there. You can see for the moment. Anybody else who doesn't have a laptop? So 3, 4 people don't have. So those who have, please let the others also see what you are doing. So because it is important that you do what your hand. It is very important. Okay. So what we do is, in case of a, if we go with the previous slide, so what we have is we have got this static declaration. We are telling that okay, we have an array called numbers. It has got a 5 in size. When we go for dynamic declaration, we will not specify the size initially. Instead, what we do is we just declare an integer pointer. This integer pointer will be upgraded to become an array. So being said that, and being you all already have gone through C programming and pointers, can you say why this can be done? What is the reason for which this can be done? So this question is actually an interview question that I'm asking you. That why can we use an integer pointer to behave like an integer array? What is the reason? What do you think, anybody? So what does a pointer do? A pointer points to a address of a variable. Okay. And pointer arithmetic, you know. So if I have a pointer, suppose this ARR is a pointer. If I write ARR equal to ARR plus 1, what happens? Normally, if there is a variable, suppose there are 3 kinds of variables there. One, two are normal integer variables, the other one is a pointer. N and I over here are integer variables and the ARR is the pointer. So if I have a value of n equal to 2, suppose, and if I write n equals to n plus 1, what happens? Say n is equal to 2 and I write n is equal to n plus 1. What happens? What is the new value of n? It becomes 3. Similarly, for this ARR, suppose it points to some variable, address of some variable, and I write ARR equal to ARR plus 1. What happens? When we increment a pointer, we point to the immediate next memory location of the same type. So if I take this, then if I go on, if I have this ARR and if I initialize it to some value pointing to some address, so if I write ARR equal to ARR plus 1, I can go to the next address, after that another address. If I keep on incrementing, it will go to the next address. So what happens is, it will start behaving like an array, because arrays are contiguous memory locations and we can use them with the index. So while if I want to declare an array dynamically, I will be using simply a pointer to the data type which I want the array to be of. Okay, so what we have done, so we have taken this ARR as a pointer to an integer, and you can see we have asked the user to give me the size of the array. Like in the previous case, we did not mention the size. So if I go here, we have mentioned the size here. This is how we generally have been saying. Here we have not mentioned the size of the array. Malloc, you know this function called malloc, malloc, clf. Right. We'll know it now. So in case of arrays, we have this now, this pointer called AR. Now we want to upgrade it into a array. To make it an array, I have also asked the users to give me a value. That value I have saved in which variable? Size I have saved in which variable? Check the code and tell me. Size of the array is an user input here, and it has been saved in which variable? In n. Okay. So I will require, if the user tells n is equal to 30, then I will require this ARR point to 30 integer spaces in the contiguous type. To do that, we call a function called the malloc or a malloc. People say in different ways. We call it malloc. Malloc stands for memory allocation. Okay, so if you go to the line over here, ARR equal to, you know what is this? You know typecasting. In C, you have learned typecasting. Okay. So first see, we are calling malloc. What is inside the malloc function? What did I pass? We passed two things. One is the size which was given by the user. So if it is 30, we are passing 30 to it. Okay. And at the same time, what we are passing? We are multiplying it with the integer of say size of. We multiply by an operator size of, which takes the size of the integer variable and multiplies it with the number of given by the user. So for example, if the size of an integer variable is 2 bytes, what is the size which is allotted here? If n is 30 and size of returns 2 bytes, what is the total size? Suppose n is 30 given by the user and we have the size of returning 2 bytes. So what will be the say total memory allotted? 60. At the back, last, how much memory will be allocated? 60. 60 what? Bytes. Okay. 60 bytes. Okay. So once we are done this, once we are done with this, now we have to typecast it. Typecasting is what? I have allotted a memory which is of the size of 60 bytes. Now this 60 bytes is what kind of data will it take? Integer, character. I am working with integer. So I have to convert this 60 bytes into an integer type memory location. So that I can say this will store only integers. So I typecast it with using to int pointer. Okay, it will be integer type. So this line ARR equal to in bracket int pointer malloc n into size of int is the memory allocation that we are doing for the array. Okay. Now if you see this, this has one practical advantage when you are actually going to code. The first is it becomes flexible about the size. You don't have to mention the size, you don't have to initialize at the beginning. You are not required. Rather, at runtime, we can specify the size. So it makes you easier to code, faster. As a programmer, yes, it will be faster for you to code. Okay. Next, after this, we will do the same way like array games. So after this line, this error equal to int malloc, so whatever we have written, we will do it in the same way. So as of now, please type up to this wherever we are using this malloc. And after that, if error equal to null, up to return one, you please type and execute. See what happens. Those who have not brought a laptop, they can just note it down. You can use it later on. You can write in your own machine once you are done. Anybody done? Once you say type up to return one, okay. So you close the main function and execute only the memory allocation part. Close the main function and do it. Anyone done this side, this side?
Codes are very small, huh?
So after you've done till return one, close the the main function. Close the main function and execute. Execute it. Did you find any error? Anybody found any error? What error did you find? Ideally, if the allocation is successful, you will not find any error. If there is an error or it has not been able to allot the memory, then it will tell you that it is not allotted, has failed. Once you have done with this, remaining you can use as like normal arrays. So you can work accordingly. So similarly, if I go with a two-dimensional array, if I, don't worry, this all the slides I'll give it to your department. You can have check. So in case of the 2D array, so what is the two-dimensional array? Rows and columns. So in case of a 2D array, what we have is we have a slight different mechanism for initializing and declaration of the same. What is the difference? Difference is over here every element is indexed by two values, one a row value and a column value. Okay. Say it's the same way we are located, any place is located in Google Map. How is a place located in Google Map? How is the place located in Google Map? So suppose you are locating a place, you are searching for some place. How does it locate? It does take help of something called the global positioning system. Now what is this GPS? This GPS is a very large array. It's a very large two-dimensional array where every place has got two values. What is the value? Whether it is north or south, or whether it is east or west. So similarly, it's like a graph paper. You have used graph papers, so it's like a graph paper. Okay. So similarly, in case of 2D arrays, it's like a graph paper. It will show you this rows and columns. We have the same thing. In case of a graph paper, we have the same. We locate in the same way. How many rows are there? Units in the x direction, units in the y direction. From there we actually relate. So how do we initialize or how do we declare in a static way? We say the number of rows which are there and the number of columns which are there, and we initialize them in the per row. So 1, 2, 3, 4 is the first row, 5, 6, 7, 8 is the next, and 9, 10, 11 and 12 is the third row. Then we print it. This things I believe you have already done. You know that how to initialize and declare a static array which is 2D. Now similarly, if I go for dynamic declaration of 2D arrays, that becomes a little more intricate than the static one. So what are we doing here? We have, if I go with the dynamic allocation of the one dimensional array, how did the pointer look like? This pointer looked like a single pointer. Okay. Single pointer. Now we have rows and columns. So we will be require a pointer to a pointer. I will require a pointer to a pointer. Now you can ask that we already have a static method of doing it. Why do I need to know this can also be done? It is because when you actually solve problems, dynamic allocation of memory is a better process in writing codes. It gives you more control. And you have to write less. So if you know maybe the first time or the second time, since you are not used to using pointers that much, for example in C or C++ or whatever. So once you know that this can be done, it becomes very fluid, it becomes very simple because you don't have to keep on writing the square braces. Writing the square braces takes more time than writing your first brackets. Okay. So over here we do the same thing, but here there are two pointers now. There are two pointers. So what are we doing? In the first example over here, we had a single dimension. That means that was a single row. Single dimension means there is only one row. And when I am going for two dimensional, there are multiple rows. So the idea behind declaring in the dynamic memory allocation for 2D arrays is we first allocate the rows, then for every row we allocate a array itself. So if you see how a 2D matrix looks or a 2D array looks, you will see these are nothing but single row arrays stacked over one another. Right? Can I tell that? It looks the same way, right? So arrays stacked over one another. So in that case, if we decide the rows first and then for every row we declare an array, then we ideally will have the rows and the columns built. So here when we are going for a dynamic declaration of the 2D array, there are two phases. The first is, see, the first malloc is only for the rows, number of rows. The first malloc is only for the rows. That means we first allocate the rows. We first allocate the first element of the rows. Next, if I go allocate memory for each row, then every row has a specific number of columns. For every row, we are now calling malloc with the number of columns. So we first declare the rows, then we have the columns. Okay. This is what dynamic array declaration works. Now, what operations can we do on an array? What are the common operations? The common operations are, you have declaration, insertion, deletion. Obviously, deletion in array is a logical deletion. You will see. Update values, searching, and also we can sort an array. So searching, sorting, have you done? Searching and sorting you have done. Okay. Deletion have you done? So if I ask you to delete a value from an array, say for example I have this insertion, I have 10, 20 and 30. If I want to delete 20, how will I delete? How will I delete? In an array, ideally you cannot physically delete a value. So what we do is, there are two kinds of deletion that we have in an array. One is a logical deletion. In the logical deletion, what happens? For example, if I want to delete 20, I will overwrite 20 with whatever is next. So 30 comes one ahead. All the elements after the element which is supposed to be deleted is copied one space ahead, one index ahead. So what happened? 30 now overwrites the 20 and my size of the array goes down logically by 1. It is not physically, because we are only doing a copy operation, so whatever is there remains. Logically we are doing it 1. For example, sorting you have done, right? Selection sort you have done. So how does selection sort work? Anybody? What is the logic behind selection sort? So in case of a selection sort, we entirely, with every pass, we take the smallest number in the array and put it in the front, and logically decrease the size of the array by 1. So next time that element is left, the other element are taken into consideration. So this is called logical deletion. And the second type of deletion, which is not logical but is kind of a value deletion, what we do is we change the value of the to be deleted object with -1 or anything which is not going to be in the scope of the values the originally variables are supposed to hold. For example, in that case, this 20, if I want to delete, I can set 20 as -1. So what happens? That is so all values which are supposed can be -1. So by looking at the array, somebody can say those are places which are not to be read. All -1 places are not to be read. But that is not a very good way of deletion. Rather, this logical deletion, if you really want to delete from an array, it is a better option that you copy the remaining values 1. Okay. Searching also, I believe linear search and binary search both, I think you have done as programs. Right? Now we come to the most important part of the thing, how exactly to solve a problem using an array. Now those who have your laptops, over here I have taken 4 programs. four problems I have taken. First two are simple problems, like deletion we have seen and reversing we have seen. These are common. Now, third and fourth is what we shall be focusing more on. So, those who have laptops, please open leetcode.com. Please open leetcode, LEET. My objective over here is to give you an idea about how actual problems look like, how you will be expected to solve. Okay. One is open, LeetCode. So you may need to log in through your Google account. That you can do, not a problem, I believe. So once you are done with this, go to problem number 26. We are going for problem number 26. Just raise your hands if anybody has opened this page. This page has come. Problem number 26. What happened? So leetcode.com, you go to problem number 26. So what you have here, this is a problem that will remove duplicates from a sorted array. Okay, remove duplicates from a sorted array. So in this, you will find there is a problem description. Okay. Now this is the actual format that you actually get in terms of where you practically demonstrate your coding skills. Okay. So you will have a problem description and you will be given examples, that is what is expected as an output. Okay. And at the same time, you will have on the right side, you will have place where you can code. You can write your submissions and there will be unknown test cases. Now this is what is very vital in terms of actually coding a program. Sometimes we write a program, it works. Sometimes we have devised some logic, it works. But is it really correct? How to assess? The way of assessing is to go to a platform like this where they have problems as well as the test cases. Now, if your logic says both the test cases, 2, 3, whatever test cases are there, if it passes both the test cases, then your logic is correct. That is, it can execute and can give output as required. The quality of the output in terms of complexity of time and space is a different thing that is also there, but we are not going to that at this point of time. So, how many of you have got this page? Right. Now, see the examples which are given. That is what is expected out of you. What is expected out of you with respect to this problem. So, what is expected? That if the numbers are 1, 1 and 2. So, first thing, the array has to be sorted. You have to enter the array in a sorted manner. The output should be 2 and the number will be 1 and 2. If you show only 1, the first duplicate will be removed. Similarly, The second example is 0, 0, 1, 1, 1, 2, 2, 3, 4. The final output will come as 0, 1, 3, 4, and the output the count will be 5. That means it will tell you how many distinct elements are there in the array. So given this, there are also certain things you will find called constraints. We'll also find certain things here called the constraints. What is the constraint? Constraint over here is the length of the array should be between 1 and 3 into 10 to the power 4. That means it should not be an array more than length 30,000. Okay. The numbers can be from minus 100 to 100. And the numbers are sorted in non-decreasing order. Non-decreasing means ascending order. Now given all this, now we have to write the code. So now so what we understand here, while we write a code, given a problem like this, how will you solve the problem? What will be your take, or how will you approach? What would be your take? Anybody can just give me their idea. But what would be the take? How exactly will you solve? So we have a problem, say description. We have a example, and we have the constraints. And we have also been told that it will use an array. So how to solve it? Any logic? Anybody? How to solve? So let's see how the code section ideally looks like. Okay. So this is a code section. Now what is the so again one advantage of writing code in this platform or any of this is a competitive coding platform. Okay, so you can those who are interested in coding, those who like coding, they can register and you can solve problems, go in for contest, everything you can do. What is the advantage is they will not ask you to write the entire C code from stdio.h and everything. They will not ask you. They will ask you to build one function which solves the problem. They will provide the test case. The internal environment will run the program with the function and the test case. So what do we have here? So they have given us, so ideally they give this thing. They will give this function prototype. They will give it to you. You have to use your say logic according to that. You can change and also do, not a problem. Now, what are the arguments passed to this function? What do we have here? We have int pointer nums and int nums size. What is nums? Nums is the array. Nums is the array. Now see, this is the same way we declared a dynamic array. They have used a pointer over here. They have not used any array symbol. They have used the pointer. That means it is evident that using the dynamic allocation for arrays is ideally a common requisite for professional coding platforms. Okay. We have the arrays and we have the size. We will have the size. Now, the size of the array, here also you don't have to put. What you do, why? Because they have the test cases, the background work they will do, the system will do. You will have to write only the logic with which we want to solve the problem. So what was our problem? Our problem was Given an array which contains values in ascending order, we wanted to remove the duplicates. So what did we? How to remove the duplicates? This is the simple. You can make this code more complicated. I have kept it as simple as possible. It's a simple logic we have done. What is the? What can you do? What can you do? So what we have done? We have taken one loop. One loop is there, and we have initialized one variable I as 0, and we have taken a loop. What is this loop going from? It is going from 1 to up to how long? Num size. That means it will go from one end of the array. And what are we doing inside? We are making some checks. What checks? That for a given value of I, we go through all the values of the array. We take one value of I, and when we go for the j loop, we go for the all the values in the array. And what do we check? We check that if there is any consecutive value which are different, okay, we simply copy that different value to the previous place. So if I take this example, say 0, 0, 1, say I is equal to 0. Now we have 0 over here. Okay. Then we have from here, if I start j, if I start j here, so j starts from the second 0. J will start from the second 0. This is 0, this is index 1. From here, it will start counting. Where does it find anything which is not equal to this nums of I? I is 0, so nums of 0 is what? Nums 0. Nums 0 is what? 0. Nums 1 is 0. Nums 2 is 1. Whenever it is finding that nums I is 0, not equal to nums j, any value of j for which the value in the array is different from the value of I, it increments I, makes I that which is done will go to the next one, and it tells nums I equal to nums j. So what happens? This one comes here. This one comes here. So I plus plus. So it found from here. It was 0 here. Okay. Please interrupt me if you don't understand. This logic is important for you to understand. Those who are having the laptop, please execute. Please execute and check. So we have a 0 here. So I is equal to 0. Right? And this is, I start from j equal to 1 here. So we are going with the loop. Now when it comes to here, j is equal to, what is the value of j here? What is the value of j here? J is 0. Right? J I am starting from 1. So j1 is here, j is 2 here. Okay, j is 2 here. So when I come to this one over here, when I come to this one over here, the value of j is actually 2. I was 0. Nums I is 0. So when I come to nums I equal to 0 and I get nums j equal to 1. So I'll just write here for your understanding. So at the first level, okay, I'm just telling you what the first iteration looks like. So I have I equal to 0. I have I equal to 0. And my value of j first starts by 1. So at this point, what is nums of I? What is nums of I? Look at the array and tell what is nums of I with I equal to 0 and j equal to 1. Nums of I is 0. Fine. Nums of j is j is equal to 1. So nums of j is 0. If j is equal to 1, nums of this is also fine. Then j increments. J starts from 1, then j increments to 2. I still remains 0. So I still remains 0. So I still remains 0. J becomes 2. Now what is nums of I? It is 0. Nums of j is equal to 1 now. Okay. So now if I go with the logic, now we have found a different value. Now we have found a different value. So that means for j equal to 1, the value was not different. That means j equal to 1 was a repeating term. It was a repeating term. So what I do is, so now we set I equal to I plus plus. That is I equal to I plus 1. So what I do is, so I was 0. Now I becomes 1. And then I copy nums I equal to nums j. What was nums j? It was 1. What is nums I now? Okay. So nums I equal to 1 was 0. Now it becomes 1. So this duplicate value is now removed. Similarly, we will go through all the values one by one till at the beginning all the distinct values are there. And at the same time, finally, when we are returning I plus 1, that means this I actually gives me the number of distinct elements. It will give me the number of distinct elements. So I am returning I plus 1. Why? That is I plus 1 will give how many distinct elements are there. So now if you want to look or see the array itself, you will run your loop from 0 to I plus 1 and print the array. You will get the entire distinct array with non-duplicating elements. So this is an example. Okay. This is an example that we have. See, what did we understand from this? Understanding is when we are solving a problem, I'm taking arrays only because my topic over here is arrays. So when we are solving a problem with arrays, we have to always understand that what kind of manipulation is required. Okay. So what is the manipulation here? That logic itself is the manipulation which will be done on the array. What is the logic? That I will traverse to the array, take one by one all elements from the first and the remaining I will traverse. Wherever I will find a non-duplicate or a new element, I will copy that and put it and replace it with a duplicating one. So what happens? These two zeros were here. Two zeros were here. The moment we found one, we removed 1 0 and we put it as 1 over here. Similarly, again, if I go with now, I becomes 1. Okay, I becomes 1. So from here again, they will search for 1. Whenever there will be some non-duplicating, it will come and replace the duplicating value. Now the question arises that how would you be able to find out this logic? That it might work that way. For this, it is important that you solve questions of this kind. Okay. Now I'll show you another question that you can say think of solving your own way. You go to problem number 62. You go to problem number 62. Problem number 62. You can go to the problems. There's a problem list. You will find, you will go to 62. Or you can search over there by unique path. You will get problem number 62 first. There are two versions of this. You will go to unique paths, only unique path. There is another one you will find as unique path 2. Not to 2. You will go for the first one. See over here, in the previous one, we had a mention of something called array. It told explicitly that we want to remove duplicates from a sorted array. Here there is no mention of what we are supposed to use. It is just given a problem. Problem is given what? There is a grid. This can also be a grid. We have this thing. We have a grid over here. So it says there is a robo on an m cross n grid. A robo is standing over here. This robo is supposed to go from here to the finish. Last one. Starts from the top left and it will go to the bottom right. There is one constraint. The constraint is the robo can move only towards down or right at any point of time. That means there are only two possibilities that the robo will move. One is the right, the other is a down. The question is we have to find out, given the number of rows and columns, so given the number of the grid if we define, we'll have to find the possible unique paths, number of possible unique paths that the robo can take to reach the bottom right quadrant. How would you solve? How would you solve? What to do? Anybody, any guesses? So given a problem statement to you, how would you solve it? How would you solve? What will be your first consideration? What does the first line say of the problem? What is the first line? Can you just read it out? First line of the problem. What is the first line? There is a robo on an m cross n grid. This is the first line. So your problem's solution will start from an assumption that since it is on a grid, it will be an 2D array. So from here we will understand that we will require a 2D array. Okay. This is the first consideration. So by looking at the problems, what is the statement is given, we know that this is a m cross n grid. The robo is required is over there. M and n are the number of rows and columns, and the robo is supposed to go from, if this is an array, this is the 0 0 position, to here it will go to m minus 1, n minus 1. Okay, this is n, this is n, this is n. Okay, so it will go from the grid 0 0 to grid m minus 1, n minus 1. This is what we need to do. What we have to calculate, or what do we have to understand here? That is the number of path. How will I understand the number of path? How will I understand the number of path? So let's see. Some examples are given. So one example, m equals to 2 and m equals to 3 and n is equal to 2. One example is given. That means m is number of rows and n is number of columns. So how many paths can be there? So if the robo wants to come here, where my mouse pointer is, say for example, it wants to come here. How many possibilities are there? Two possibilities. So it comes here and here, here and here. Two possibilities. Similarly, if I make it 3 cross 2 now, 3 cross 2. How many possibilities? One is it can come here, here and here. It come here, here and here. It can come here, here and here. Three possibilities. So if I expand it for more number of cells, is there any pattern? Is something working that you can establish? So let's check over here. So we have the robo was supposed to come here. What are the possibilities? Two possibilities from here and here, here and here. Two, either it goes here and comes here or here and comes here. How many steps does it take here to here? One. From here, one. If I add these two, I'll get this one. I'll get this one. So to reach any of the cells, so to reach over here, these two has to be added. So let's go to the program itself. Let's see the program. We'll wrap up after this program is done. This is anyhow related in Java. Just have to just see the logic over here. Just have to see the logic over here. That is, this is first loop is for rows. Second loop is for columns. And any K and L, that is any cell is given by K minus 1 L, which is this cell exactly on the top, and K L minus 1 exactly before that. So to calculate the number of steps, we start with 1 over here. Obviously, y equal to 0 or j equal to 0, this from here and here will be 1. That we initialize. Remaining all, it will go with any k and l will be k minus 1 L and K L minus 1. That is sum of immediately what is on the top and what is just before. Okay. This is how we actually solve. Okay. Now, for me it is easy because I have been solving. For you it won't be. How to make these things easy? So, to getting this thing done, the first thing you need to do is you have to enroll yourself into any of the competitive coding platform. This is one is called Lead Code. There are multiple. There is HackerRank. There is CodeShare. There are thousands of there. And you have to solve. You have to solve problems. There are thousands of problems that you see every day. Start with two. Start from easy. They all have. So if you go to the problem list, they have got classification: easy, medium, and hard. You can start with the easy ones. See how it works. Per day 2, then gradually increase. So that by the time you reach your fifth semester, you become at least 50 to 60% proficient on at least finding out the solution when it is given. And in majority of cases, when you will be sitting for your internship, when you will be sitting for your placements and anything of those kinds, these platforms, these problems are from where the companies even pick out problems and give it to you for solving. So if you make it a habit from now, since you are in a third semester, you have a lot of time now, at least not a lot of time, 4 semesters you have before you start off with your internships or your things. 2 years of time. If you make it a habit that every day I'll do for 1 month, two programs I'll do. If not, two is hard, you take it for one, at least one program every day for 1 month, then two programs every day for the next month, two, three. Every month you increase the frequency of the solution. It will help you in understanding the total problem base. Because there are many, for example, if you go to the next problem, 63, it will be unique parts 2, similar to this, with a little twist. So if you know how to solve this, you will be able to solve that also. So if you are able to solve both 62 and 63, then possibly after say keep on solving, after 1 month or 2 months, you will be able to solve all problems of the similar type. Because it will be like in class 8 and 9, we used to have this factorization. Remember algebra, we had about factorization. So how did we remember? Because factorization came as pattern. Well, when you had gone with integration and differentiation, integration by the substitution method, you knew that if something looked like this, we have to take that as z or t, and then we have to differentiate and do things accordingly, right? That is how we have learned. Programming is also the same way. You have to understand the problem base. So 15 problems, 20 problems of a similar kind, if you are able to solve, you will be able to solve all problems of the problem. The idea is to not only with arrays. So unfortunately, I had only this 1.5 hour of time to talk, and I had only arrays to talk with. With everything that you have, arrays are the most common thing which you will be using for problem solving. Most common of data structures. Okay? So with this, make it a habit that you solve problems. Just by learning syntax and knowing the features will never be sufficient enough to make you into a good programmer. You have to solve. You have to work it out. You have to make this device push to its hardest. Then possibly, and by that time when companies will come, you will be posing yourself as potential candidates. Now companies want people who can code and who can solve problems. Okay. So with this, I'll wrap up my session now. So anything, any doubt you have, any question? I will share the say presentation with you all. So you can take it as a reference point. You can do that and make sure uh, till we meet next time again. I will expect you all to have a better understanding and you should make coding a habit. Computer science students, coding should be their best friend. Thank you very much.